In this lesson, we find the sum of geometric sequences. The sum of the first n terms of a geometric sequence, s sub n equals a plus a times r plus a times r squared plus all terms in between up to plus a times r raised to the power n minus 1 is s sub n equals a times 1 minus r raised to the power n over 1 minus r if r is not equal to 1, s sub n equals n times a if r equals 1. Let's find the sum 1 plus 2 plus 4 plus etc. up to plus 32. Here r equals 2 and r is not equal to 1, so we can use the formula s sub n equals a times 1 minus r raised to the n over 1 minus r. We know that a equals 1 here, but what is n? We don't know how many terms there are, so we'll have to find n. We can use the formula a sub n equals a times r raised to the power n minus 1, plugging in 32 for a sub n, 1 for a, and 2 for r, and we will then solve. We have 32 is equal to 2 to the fifth. That's equal to 2 raised to the power n minus 1. 2 to the fifth equals 2 to the n minus 1 if and only if 5 equals n minus 1, which results in n being equal to 6. So we know that we have 6 terms here. So s sub 6 equals 1 times 1 minus 2 to the 6th over 1 minus 2. Simplified, that's equal to negative 63 over negative 1, and so S6, the sum of the first six terms, is equal to 63. Geometric series. A series is the sum of a sequence. For the infinite geometric series, a plus a times r plus a times r squared plus terms on to infinity. If the absolute value of r is less than 1, the sum is s equals a over 1 minus r. If the absolute value of r is greater than or equal to 1, the sum is not defined. Note that if the absolute value of r is less than 1, the series converges. In fact, we will say the series converges to a over 1 minus r. If the absolute value of r is greater than or equal to 1, the series diverges. Let's find the sum 2 plus 2/3 plus 2/9 plus etc. and terms going on to infinity. R equals 1/3 here. A equals 2, the first term. Because the absolute value of 1/3 is less than 1, we can use the formula a over 1 minus r. So 2 plus 2/3 plus 2/9 plus terms on to infinity equals a over 1 minus r. We plug in 2 for a, 1/3 for r. We have 2 over 1 minus 1/3, which simplifies to 2 over 2/3 and simplifies further to 3. So the sum of this series that goes on to infinity approaches the number of 3. Let's express the repeating decimal 1.23 repeating as a fraction of integers. 1.23 repeating equals 1 plus 0.232323, etc. 0.232323, etc. we can write as 23 over 100 plus 23 over 10,000 plus 23 over 1 million, and we could keep going there. But this is enough to tell me that a, my first term here, is equal to 23 over 100. R, the number I multiply each term by to go to the next one, is equal to 1 over 100. So I can use the formula, the sum of this infinite geometric series is equal to a over 1 minus r, 23 over 100 over 1 minus 1 over 100. That simplifies to 23 over 100 over 99 over 100. Simplifies further to 23 over 99. So I have 1 plus 23 over 99. That's the same as 99 over 99 plus 23 over 99. So I found that this repeating decimal, 1.23 repeating, is equal to 122 over 99. Try on your own. Find the sum of the series 1 plus 1/5 plus 1/25 plus terms on to infinity.